So last time we were talking about stoichiometry of reactions, and we said that's all the math associated with the reaction. And we had introduced the concept that we could use the coefficients in the balanced equation as a mole-to-mole ratio to allow us to figure out how much of something we were making. We had done several problems using moles, and then we had combined that with molar mass to find grams. And the last concept we had worked on before we ended last week was to look at the limiting reactant problem. And we said that we recognize limiting reactants how? Do you remember? Because when we read the problem, we have the amounts of two different reactants given. This is a really important step because when you see these in the homework or on the test, you have to be able to recognize them to know that you're going to do two calculations. So when we look at this, how much manganese metal can be produced from 50 grams of manganese oxide and 25 grams of aluminum, we recognize that we have two reactants here, amounts of each, and so that tells us that it's a limiting reactant problem. So we have to do several things. The first thing we always do is check and make sure that the equation is balanced. And when we look at this one, we can see that it is not balanced. So when you look at this, you say, well, 2 aluminums and 1 aluminum, and your first gut reaction would maybe be to put a 2 here. But then when I look at the oxygens and see I have 3 oxygens here and 2 there, that tells me I've got another issue. So I'm actually going to start with oxygen. These are 2 fairly involved molecules, so I'm going to start by multiplying this by 2. Now I have 2 times 3 is 6 oxygens, which is an even number. And since these come in pairs, it's easy now to balance manganese and oxygen by putting a 3 in front of the manganese oxide and a 3 in front of the manganese. Now I have 2 aluminums times 2 gives me 4. So now my equation is balanced. Now, I'm asked about manganese metal. I want my answer in manganese metal, and I have manganese 4 oxide and aluminum. So it means I need the molar masses of all 3 of those things. So the next thing I do is grab my periodic chart. So the manganese oxide, 86.936849 grams per mole. The aluminum, 26.981538 grams per mole, and the aluminum oxide 101.961276. Oh, and I actually don't even need that. And the manganese 54.938049 grams per mole. So I found the molar mass of everything. Turns out I don't even need the aluminum oxide because the question doesn't say anything about aluminum oxide. So now we have balanced the equation and we found the molar masses of the things of interest. Now what we're going to do is to do 2 calculations. We'll do one calculation, seeing how much manganese I can make if I use up all the manganese oxide, and then we'll do a second calculation to see how much manganese we can make if we use up all of the aluminum. Then we compare the 2, and we choose the smaller answer. So again, you can start anywhere. I always like to start with the unit I want on top and how much manganese metal. So I'll start with the molar mass of manganese. 54.938049 grams of manganese is 1 mole of manganese. Now that's the unit I want to keep on top, so I have to get rid of everything else. So now I look at my balanced equation, and I'm interested in calculating with the manganese oxide. So I know that 3 moles of manganese comes from 3 moles of MnO2. So I've canceled my moles of manganese. Now I know that 1 mole of MnO2 has a mass of 86.936849 grams of MnO2. And now I have canceled my moles of MnO2. I need to cancel my grams of MnO2. And I have 50.0 grams to start with. So if I use all of this up, I can make 31.6 grams of manganese. So now I'll save that answer and set it aside while I do the next calculation. The next calculation is to figure out how much manganese I can make if I use up all my aluminum. So I start the same way with the unit I want. 54.938049 grams of manganese is 1 mole. From my balanced equation, 3 moles of manganese, but now I'm comparing it to the aluminum, gives me 4 moles of aluminum. So I've canceled moles of manganese. Look at my aluminum. 1 mole of aluminum has a mass 26.981538 grams of aluminum, and I know that I have 25.0 grams of aluminum, so I get 38.2 grams of manganese. So I've calculated how much manganese I can make from each of the 2 reactants. Now I compare them and I choose the smaller answer. So the correct answer is 31.6 grams of manganese because it is the smaller of 2 amounts. So as you're doing these limiting reactant problems, you read the problem. You recognize that it's a limiting reactant problem because the amounts of 2 reactants are given. You look at the equation, make sure it's balanced. If it is, fine. If not, balance it. Then you find the molar masses of the components of interest. Then you calculate how much product you can make from each of those reactants and choose the smaller number. Okay, go ahead and try the next one at your seats.